Okay, problem 3. Decide whether the series is absolutely convergent or not. Okay, so we say a series is absolutely convergent. Okay, we say a series is absolutely convergent if both its absolute series and itself, right? So if the absolute series is convergent and itself, it's also convergent. Okay, but usually we just need to prove the absolute series is convergent, because if the absolute series is convergent, the original series is automatically convergent as well. Okay, it can be proved. So to prove a series is absolutely convergent, you just have to prove its absolute series is convergent. Okay, so we have absolutely convergent, so we have conditionally convergent. So what is conditionally convergent? That means its absolute series now is not convergent. Its absolute series now it's divergent. Okay, but its original series is convergent. Okay, so in this case we call the series conditionally convergent. And we call a series divergent if both its absolute series and the series itself, they are both divergent. Okay, actually, if the series itself, right, okay, if the series itself is divergent, then its absolute series is automatically divergent. Okay. So here in 3a, we want to find whether this series is absolutely convergent or not. Right, so what should we do? Right, so this is the series itself. Then all we need to do is to find the absolute series. Right, then what is its absolute series? Okay, what is its absolute series? So we just put an absolute value here. And you can see it doesn't change anything about the bottom. The bottom, the factorial is always positive. Right, the top. So here I have negative 3 to the power of n. So if I put an absolute value, the top will always be positive 3 to the power of n. Right, so the absolute series is just positive 3 to the power of n over 2n plus 1. Okay, and for this series, I can just check, use the ratio test. Right, I can just apply the ratio test here. So I can get the limit of an plus 1, its absolute value over an. Okay, so an plus 1, it is 3 to the power of n plus 1 over 2n plus 1 plus 1, right, factorial. Okay, over an. So an is 3 to the power of n over 2n plus 1 factorial. So this part, right, this 3 to the power of n plus 1 over 3 to the power of n, that is 3. Okay, then I have 2n plus 1 factorial over 2n plus 3 factorial. So, for example, 9 factorial over 7 factorial, because it's 9 times 8 times 7 times all the way to 2, 1. Right, over 7 factorial is 7 times 6 times all the way to 2, 1. Right, so you can see these two parts, they can be canceled out. So the only thing left is 9 times 8. Okay, so it's the same thing here. So the only thing left is just 2 more terms of the bottom than the top. It's 2n plus 3 and 2n plus 2. Okay, and obviously this limit is just 0. Okay, because we are doing a ratio test, the limit is 0. That means the limit is smaller than 1. Okay, the limit is smaller than 1, so that means these, right, these absolute series is convergent. Okay, so the absolute series is convergent, then the original series is absolutely convergent. Okay, then the original series is absolutely convergent. Okay. So we can do the same for part B. Okay, for part B we have n from 1 to infinity, 1 minus n over 2 plus 3n to the power of n. Okay, so we just have to apply the root test. Why root test? Because I have to the power of n here, right? So if I nth root of this thing, then these two parts, they can be canceled out. So I just have to do the root test to the absolute value of an. Okay, so it is the limit n is approaching infinity, the nth root of, okay, you can see if I take the absolute value, right, as n is greater than 1, this 1 minus n is smaller than 0. So if I take the absolute value, it will be, the top will be n minus 1, the bottom is 2 plus 3n. Okay, so it will be n minus 1 over 2 plus 3n to the power of n. Okay, then it will be the limit of n minus 1 over 2 plus 3n. So here I can divide the top and the bottom by n. So I have 1 minus 1 over n over 2 plus 3 over n. Sorry, 2 over n plus 3. Okay, so when n is approaching infinity, it is 1 over 3. It is smaller than 1. Okay, so this absolute series is convergent. Okay, this absolute series is convergent, then the original series is absolutely convergent. Okay.